Hello everyone, this is Huma Lodhi. Thanks to organizers for inviting me. My talk is about the journey from data to value with machine learning. Huge amount of data is generated every second. A challenge which many organizations face is how to transform this into actionable insight so that this valuable asset can reach its potential. In industry, there are many operations which can be automated or semi-automated by exploiting the information which is contained in data. There are many decisions which may be based on historic rules, and these rules are not relevant today. Ideally, decisions should be supported by data. However, creating a data-driven organization requires investment, but a right strategy makes this investment worth. Machine learning is a key technology to extract insight from data. I would like to give a brief overview of this interesting field of computer science. The term machine learning was coined by Arthur Samuel in 1959. In this area of study, computer systems learn from data and past experiences to take intelligent decisions with low error probability. For example, in oil and gas drilling, measurements are collected from sensors and other tools. A machine can be trained in conjunction with this data to improve drilling operations and to generate low carbon solutions. There are different types of machine learning algorithms, for example, supervised, unsupervised, and reinforcement learning. Generally, supervised machine learning algorithms perform better. Then there are different classes of machine learning, ranging from deep learning to inductive logic programming. These different classes of machine learning share some characteristics but also have some individual characteristics. Ideally, one would like to have an algorithm which has all the desirable characteristics from different classes of machine learning algorithm. As we are discussing machine learning, we can look at the fundamental benefits of these methodologies and classical statistical approaches so that we can select a right approach for a given problem. Standard statistical methods require prior knowledge. They are good for small data and few variables. They have a limitation, which is that generally these approaches do not generalize well. Machine learning methods work well with or without prior knowledge. They learn from big data and many variables. One of the key benefits of these approaches is that they have high generalization ability. And generally, for a given problem, a machine learning method can provide us an accurate solution. We now have a technology to extract insight, but the questions arises regarding data readiness and its accessibility. For example, data can live in silos, and this poses a big challenge. Then it can appear in any form, for example, Excel sheets, PDF document, or an image embedded somewhere. It's extremely important to have automated data pipelines which address all these different types of issues. Data appears in different types. For example, we can have structured data Handling such data is easy. Data can also appear in textual form or in the form of voice, for example, customer calls. There is another type of data which we see a lot, and it is images. In finance and energy sector, data often appears in the form of time series. It's crucial to understand how the data is characterized. For example, are there missing values, or is there noise? Regarding noise, it's important to differentiate between a human and a tool generated noise. Processes where humans are involved in data collection, noise can be added due to human mistake. But this noise is different than a tool noise like sensor noise. So it's important to identify different types of noises, and then data should be handled accordingly. Missingness is also a very important characteristic of data. Missingness can be random, but it can also have a pattern. For example, someone who wants to commit a fraud may not provide details which should have been provided. So if there are some missing information like this missingness has a meaning and it should be handled differently than random missing information. There are different ways through which we can handle missing information and noisy data. For example, we can handle through algorithmics, or we can use simple statistical approaches to address these issues. Then, during the development of our algorithms, we would also like to incorporate all of the domain knowledge that is present and also extract information from different data types that are available. To build data-driven systems, the underlying model should be expressive. When a decision is being taken by a computer, it's important to understand and identify the factors which have contributed most to make that decision, so that an explanation could be provided to a user. Now the question arises, do we have an algorithm or a class of algorithms which can address all different types of issues and can provide us with an optimal solution for a business problem? The answer to the question is yes. Deep learning can somehow provide a solution to business problems. Although these approaches are not perfect and have limitations, but these provide a good starting point to generate data-driven solutions for business problems. They have been useful in industries ranging from insurance to oil and gas. In insurance, we can apply these approaches to solve a range of problems. For example, claims can be handled by using these methods. Generally, it takes days and months to resolve a claim. However, with the help of deep learning methods, we can resolve claims in minutes or seconds. We can also use these approaches to compute insurance premiums, and by using these techniques, we can compute personalized premium that is desirable. We can also use these approaches in health and other industries. We can now consider some examples for deep learning based data driven solution. A deep network has been successful in learning with data of different types for a few business problems. So the network learns a representation for each different data type, and then the learned representation is combined into one and it is further refined. So for example, if we have data that comprises categorical variables, numerical values, and binary values, we can learn a representation for categorical variables, and this representation will have all the information which is contained in categorical data. Then we can learn a representation for numerical data, and the same applies with binary variables. So in this way we are learning three networks in parallel, and we are learning representations for each different types. Once we have learned a representation for each type, we combine this into one representation, and then we further refine it. Finally, we have a representation which contains all the information which is required to solve the problem. And this representation has been successful in quite a few business problems. We can also use deep learning to learn from textual and structured data, or from textual and image data. So this is another example where we have data in the form of text and also some structured data, where structured data can have categorical and numerical and binary values, and text can be free text, notes, anything. So what we can do is that we can learn a representation for text, and then we can learn a representation for structured data. Once we have representation for each different type, and this representation has all the information, then we combine it into one and we further refine this representation. And finally, when we have learned a representation, or we have features, then we use this representation in conjunction with a classifier or a regressor, and then we solve the problem that we have at hand. Let's now see a few use cases where these advanced methods can generate business values. We can look at insurance industry. Insurance is a centuries old industry, and it can be considered as comprising three functions: claims, pricing, and customers. And in all of these functions, we can apply machine learning techniques and can generate business value. So for example, in claims, we can determine liabilities. In addition, we can also solve total loss problem with the help of advanced techniques. Fraud is a big issue, and due to fraudulent claims, insurers lose huge amount of money. By using these advanced techniques, we can identify fraudulent claims, and in this way, we can save millions of pounds. Pricing is the most important function within the insurance industry, and we can use machine learning techniques to generate smart premiums, and a premium that is according to the needs of a customer. So for example, ideally as a customer, I would like a premium that is for me, that is not for my neighbor. And the advanced techniques provide us with the means so that we can compute premium that is according to a customer. And in addition, we can also optimize those prices. For example, if a for example, circumstances for a customer changes, we can we can change the price with the help of these techniques in real time or near real time. So there is a huge benefit of applying these techniques within the insurance industry. Customers are very important because we the aim is to provide value to customers. So, for example, we can have, for example, if we have developed a product, we would not like to send an email to all the customers. We should focus only to customers that may be more interested in the product. So we can do personalized marketing. Then churn and retention is another area where we can use techniques to see that how can we retain customers. So there is a huge value of applying these techniques in all different functions of insurance. Energy is another industry which can have huge benefit by adopting these techniques. And these techniques are at early stages within the energy sector, but they will provide a huge value and in different areas. So oil and gas is an important form of energy, and in oil and gas, from exploration to to everything, we can apply these techniques. For example, we can have uh, we can have these techniques for predictive maintenance within the rigs. Then drilling and exploration generates huge amount of data. That data needs to be monitored, and anomalies have to be detected. To detect anomalies and to monitor these data, we can apply advanced machine learning techniques, and all this process can be automated. Then customers, again, here in any industry, customers are very, very important. And for example, within the energy sector, we can, on the basis of weather, we can see if it is hot or if it is cold, what will be the demand for power, and then we can adopt. So these techniques will provide a lot of benefits in terms of customer services and safety and business value. So these are the few use cases for data-driven methodologies in different industries. And as I have said previously, that by adopting these methodologies, we can generate business value, we can make real-time decisions, customers can be provided with better services, revenue can be increased, and loss can be reduced. Thanks, everyone. It's been a pleasure talking to you.